the next class. So now the great equation, that is Maxwell equation, which is mainly framed for the electromagnetic waves. Without electromagnetic waves, there is no technology in this now in this world in nowadays. So the main equation we have to know, that is a Maxwell equation. So who's the Maxwell? Is James Clerk Maxwell in 1865 framed the theory of electromagnetic radiation through four different equations, and explained about the fundamental relations between electric and magnetic field. Because in the name itself, we know we have a electromagnetic wave. So those four equations are called as Maxwell equation. Two equation it is coming from electric field, and two equation which is coming from the laws of magnetic field. So what are the four fundamental laws which is formulated for the electromagnetic wave? One is the Gauss law for electricity. Another second one is the Gauss law for magnetism, and the third one is the Faraday's law of electromagnetic induction and Ampere's law. This every law I have given in previous one of the video. So now we can coming to the Maxwell equations, how it was derived. So first we have to know what's the final equation of Maxwell equation. The first equation, that is del dot D is equal to rho. The second equation, del dot B is equal to 0. The third equation, del cross E is equal to minus dou B by dou T. And the fourth equation, del cross H is equal to J plus dou D by dou T. Here D indicates displacement vector, rho indicates the charge density, and B indicates the magnetic flux density, and E indicates the electric field intensity, and H is called as a magnetic field intensity, otherwise magnetic field strength, and J is nothing but current density, rho is the charge density. Okay, so coming to the first equation, I have split my videos as two equation for one video because it is a long derivation. So in this video, we can see equation 1 and equation 2, how it was derived. So coming to the first Maxwell equation, which is derived from the electric Gauss law. So what is electric Gauss law? That is for any closed surface, the electric field intensity, which is equal to the 1 by epsilon naught times of Q, that is 1 by epsilon naught times of total charge or total flux. So according to the Gauss law of electric field, we can write the Gauss law, that is closed surface integral of E ds is equal to Q by epsilon naught. Here this epsilon naught can be coming here, that is epsilon naught E dot ds is equal to Q. So we know the formula, that is D is equal to epsilon E, but here we having epsilon naught E. So first of all, we have to compare this one. So let we know epsilon is equal to epsilon naught into epsilon r. That is permittivity. Epsilon means permittivity. Epsilon naught means it is a permittivity in air or free space. That epsilon r is a relative permittivity. So we can write this epsilon in this here. Epsilon, instead of epsilon, we have to write epsilon naught into epsilon r. For epsilon r, since it is r, the perfect dielectric for the medium, that is epsilon r is equal to 1. So here the value will become 1. Finally, we will get D is equal to epsilon naught E. This already we have this epsilon naught E in this equation number 1. So instead of epsilon naught E, what we have to substitute? D. So it was replaced. The closed surface integral of D dot ds is equal to Q. Then, so we have to get our Maxwell equation. From this Maxwell equation, del dot D is equal to rho can be derived from the Gauss law of electric field. So in the left, see the left hand side, this was converted as D. From where? Here it is, we have E dot ds. This E can be replaced as D, and this right hand side Q by epsilon naught can be replaced as rho. So in the left hand side, we got D. That is closed surface integral of D dot ds is equal to Q. Then in the right hand side, this Q we having in our, here we having Q, but in Maxwell equation we have rho. So we have to relate this Q and rho with the equation. Which equation which can this can be related, since the Total charge Q is equal to the charge density rho over the volume V. We can write Q is equal to closed volume integral of rho dV. So comparing this to equation 3 and 4, we get d dot ds is equal to closed volume integral of rho dV. So this is our Maxwell equation in integral form. Maxwell equation in integral form. So we have to derive the differential form. Then only we will get a del value. Del value. The differential form of Maxwell first equation shall be obtained from the integral form of Maxwell first equation by converting the surface integral into volume integral. So whenever the integral to be converted to differential, we have to apply a Gauss divergence theorem. Here the Gauss divergence theorem is applied only to the LHS of the equation, that is the closed surface integral of d dot ds will be equal to, that is this d. The surface integral can be converted as a volume integral when the normal vector d will converted as a divergence of vector, that is del dot d into dv. From equation 5 and 6, we can replace this d dot ds as volume integral of del dot dv. From equation 5 and 6, we can write this one, that is del dot d rho dv is equal to closed volume integral of rho dv. So both the sides, see both the sides of the integral in volume only. So the volume in two volume integrals are equal if these integrands are equal.